Hello, and welcome to our talk. So my name is Bastien, and I'm with Florian, and today we will talk about the Active Directory database, also called NTDS.dit, in order to identify the misconfiguration and vulnerability. And the purpose of this talk is also to give you to explore your own NTDS after. So we are from a French security company, security consulting company called XMCO. So we are auditors, especially for Active Directory, but also other stuff. And we are also contributor from an own solution, Active Directory solution, in our company called IamBuster, based on NTDS analysis. So today, what we will see, why we would like to analyze the NTDS. So what is interesting inside the NTDS. And also, we will have a quick look at the format and the structure of the database, and how to parse and get the data outside a Microsoft environment. And at the end, we will take a look on the trending topic, which is ACL and control path, and also present our little script to help you to dig inside the NTDS. NTDS stands for NT Directory Service. You have a copy. So this is basically a big file. Could be small, but usually it's kind of big. It's stored on each domain controllers of your domain. And the format is ESC format. It was created by Microsoft and was shipped first with Windows NT in 1995. And after, Microsoft used this format also for other Windows solutions, Active Directory as well, and Outlook. And you may be wondering why Microsoft didn't use SQL formats at that time. We didn't find any official statement, but multiple sources said it was mostly because of performance issue and technical issue. So, but if you have an official statement, we can share it after. So the story behind this presentation. So we were pen tester before in Active Directory environments, and after compromise a domain, we like to grab the NTDS and test the password strength. And so it was a kind of bonus for our customer in the report with other findings. And after that, some customers start asking us a specific Active Directory password audit. So then we start building our own scripts with Python. We were familiar with Python. And so we used Impacket at that time. And we were wondering if we can go further than just auditing password. So there's a lot of previous work on the NTDS. Joachim Mess has made a great work. He released a format specification paper in 2011, and also library in C language, libesc db. His work inspired other tools, Impacket, NTDS Extract, Airbus BTA, and we are not exhaustive here, other tools as well. And later, also Microsoft published managed ESCNT that provide access to the library, to the DLL ESCNT. I know DS Internal use it, maybe other tools as well. So a little bit more on the NTDS, what you can find inside. So all data on your Active Directory is inside the database. The size of the database could start from 30 maybe megabytes to 15 gigabytes. 15 gigabytes is actually the most biggest one we have seen in production. Maybe you guys have a biggest one. 15 gigabytes, it's like 200,000 users. And the domain was created in 2001. Because when your domain is old, you have a lot of backlog transactions, and the size of the NTDS get bigger. So yeah, so do someone has a bigger one than 15? Maybe?
One of our customers.
Okay.
600X.
It could go until, I think, 1 terabyte or something like that, according to Microsoft. So to dump the NTDS, you need domain admin rights by default, and you can dump it easily with NTDS util tool. This is the most common one. And the database is almost the same on each domain controller. I said almost, because we will see later in the presentation, some attributes value are not replicated between them. So finally, why we want to analyze it. It's an alternative way to audit your Active Directory offline. Like, you can conduct an offline audit or a light forensic in comparison to a dynamic tool, you know, like Bloodhound or Purple Knight or whatever. So you don't need to be connected to the system, the information system, or to your domain. You just need to have the file, and it's the only way to audit the password, because this is the only place you will find the password hashes. So at the end, it's useful for blue teamer that doesn't want to generate extra nodes on their network. It could be useful also, especially when you audit a sensitive environment. I know when we go to a factory, industrial factory, they don't like too much when we connect to the network and sending many requests, so they prefer like offline audits. They are afraid that we can maybe break their machine. And also it could be useful for pen testers after compromising a domain to add extra findings in the report. So we will see what could be interesting in security perspective. So you have everything on users, like activity, if they have SPN, if they are security attributes or not, delegations, and also the membership. You have the password, so the password properties, so which is you can try to break passwords with tools like John the Ripper or Hashcrack, because you have the password hashes. You have the format, LM or NT, so you can find if they still use LM obsolete format. You can detect password reuse. A fun fact is we have a customer, he has a tiering in his domain, but one domain admin is the same password on his T0 account, T1 account, and T2 account, so breaking the whole tiering. And we didn't break the password because it was strong, but you can compare the password hashes to say, OK, so you use the same password, so if your T2 admin is compromised, you can also compromise your T0 account. And you have also information about the password change date, etc. System, because every machine on your Active Directory has an account. So you have also property on the system machine. If you can detect if the Kerberos password has been changed recently or not. You have information on the trust, the way of the trust, if Labs is installed on your domain, etc., etc. And of course, ECL are part of the NTDS. I will let Florian talk about that later. A little bit feedback. We have analyzed last year 80 domains, 80 different NTDS from different companies. Password is still an issue, but I think you already know that. But high privilege accounts are less weak than before. Before we have seen more than that. We still have LM format in 2023, but it's mostly service accounts that haven't changed their password since their creation. And a thing is interesting, it's changing your password regularly doesn't make your password stronger because the user will add an extra character at the end of the previous password or whatever. So this is, we have cracked almost the same amount of password that was changed before 6 months ago and after 6 months ago. And a little bit of overview of your system in production today. So this is a good graph to see Microsoft version failed because we've never seen Windows Vista and Windows 8 maybe a couple of times, but Windows Vista never. And we have still Windows XP, Windows 2003. And today, yeah, Windows 10 is the most used for client, and Windows 2016 is the most used for servers. Other categories is non-Windows system. So Mac OS, Linux, maybe NAS storage, etc. We have talked about what we could find in the NTDS, but what is not part of the NTDS, but very interesting in security perspective. Event logs for forensic investigation are not part of your NTDS, of course, for your NTDS. If event logs were in your NTDS, it will be so big, you won't be able to read it. That's why conduct an offline forensic with the NTDS, it's very light, because you don't have event logs, and event logs are more precious because you have everything you have, if you have good logs, of course, to track user action, account action. GPO details are not part of the NTDS as well. You have GPO reference, like the name of the GPO, the ID of the GPO, the creation of the GPO, but the content, the XML file, are stored in your sysvol share on your domain controller. So you will need to go in this folder to see what exactly do GPO. ADCS templates also are not in the NTDS, as well as Windows patching level and Windows system configuration. If you want to know the last KB installed on a Windows machine, you will need to go after the machine directly and ask it directly. You just know the version of the Windows, like Windows 10, 11, etc. So a little bit about the format and the structure. So as I said before, to dump the NTDS, you need NTDS util. It dumps by default 3 files. If you run the command, as you can see here. The NTDS.file, of course, the system hive and the security hive. System hive will be useful for us. We will see why after. Here, an overview of the NTDS tables. You have more than 12 tables. Most of them are useful to run the service, the Active Directory service. And 4 of them are very useful for us because they contain data very interesting. The MIS/SysObject data table, contains metadata on all other tables, especially for the data table. The data table contains information on objects. So this is the huge one and the biggest one, and you have all information on user, machine, groups, GPU, etc. After, you have the link table, useful to know the relationship between objects, and the SD table that contains security descriptor of objects, useful to audit the ACL, ACE. So the data table could be also named as the hollow table because it's full of hole inside. Why? So you could have more than 3,500 columns. But depending on the type of the object, most of the column will be empty. So, for instance, if you have a domain object, the domain object has different attributes than machine accounts or user accounts. So it could be represented like this. Each entry represents an object, user, computer, domain, etc. And as you see, like depending on the kind of entry here, we have the column empty or filled out. It depends. But the problem is when you read at your first time the data table, you can see that the name of the column here I completely abstract for you. You don't know really what is inside. And so you can guess, maybe. Now, here we can take a look at this column, and you will see Legolas, Gimli, Aragon. Maybe this is the same account name, maybe. But when it starts to be a number, it's hard to know what's exactly inside and what kind of data is in this kind of column. And just a word on the SD table. The SD table contains a security descriptor. It's very small comparing to the data table, and only 4 columns. So we will talk about at the end of the presentation. So how you can parse and get the data of your NTDS. As we said before, the column name is abstract. So the first things to do is to go to the MC subject. And inside the MC subject, you have all the column names in your data table. And so you can grab the ID of the columns. And in the data table, you have an attribute ID columns that helps you to identify on the same line the LDAP name. And the LDAP name, it's usually more familiar for you. And when you have when you know the ATTM 590045 here, corresponding to the SAM account name, after you just need to go to this column and grab the SAM account name for your domain users. So this process is kind of boring, and you don't want to do that each time you look at your NTDS. So it's not really documented by Microsoft. I couldn't find like a really good dictionary of translation from the Microsoft website, where we just released a script that outputs all the translation between the abstract attributes and the LDAP name. It will be the same on all Active Directory, except depending on the version. If you have a Windows 2003 level comparing to Windows 2016 level, Microsoft had some attributes, of course, so you will have more attributes. The most recent your level is, the more attributes you have. So to get the data, you have different library, C like lib, ITsecurity, Python, you have Impacket, you have Dissect, in Go also. But with external library, so to get the data, you cannot use like a kind of SQL language to directly grab your data. You will need like a file to read from the beginning of the data table to the end to find your data. So here, if we want to find how many, the user that logged 10 times on your domain controller, you will need to iterate all over your data table and save the corresponding SAM account name. So reading the whole data table for a small NTDS, like 30 megabytes, it's kind of 10 seconds. But for a 15 gigabytes, it could take several hours, so you won't do that many times. So you prefer maybe read at least at once and store all the results in another database like SQL or NoSQL to request it for your audit or your forensic. If you're working exclusively on Microsoft, on Windows environments, if you can use the ManageDSC library, this one should be faster. We haven't tried yet, but we should. But this library can use internal index that Microsoft use, and it could be really faster. And maybe you don't need to store the whole NTDS data in another kind of database. This is a very basic function that reads your data table and looking for accounts that log 10 times. So you just need to specify, take this one, no, that doesn't work either. Okay. So you just need to specify which attributes you want to look at. And after, you iterate all over the data table, and you print it out, the SAM account name and the logon count value. So here, we use the Fox IT dissect library, which is great if you want to take a look. Data in the NTDS has types, of course, different types. We are not exhaustive here, but you have integer, large text, etc. In the column names, you have a letter, and this letter indicates what kind of type is inside your column. So for instance, if you have a G, it should be an integer. Should be, because sometimes we have some surprised. M, large text, etc. So just a very short list of what kind of attributes and the LDAP translation. And you have also special kind of attributes. So you have encrypted attributes for sensitive data, such as like LM and NT password hashes. Those attributes are encrypted with the PEC. The PEC, so the password encryption key, is also encrypted with the boot key. And the boot key, you will grab it in the system hive. That's why when you do like an NTDS util, it dumps the system hive. And with the system hive, you can grab the PEC and you can decrypt the NT and the LM hash. Exception, also, yeah, the boot key is unique for your domain controllers. So don't mix them up with other domain controllers of your domain, it won't work. And also the Labs legacy, so the first version of Labs, didn't require a boot key to read the password because Microsoft stored them in clear text in the NTDS. Now they released a new version last year. We haven't seen in production only once, but I think it will start to be more common, and now it's encrypted, but you can still store it unencrypted. But you can normally it should be encrypted in the future. Just a word on the description field. It's not designed to store the password, but we still see password in this field. and sometimes it's privileged accounts. So it was not designed to do that, to use it, to store sensitive information, and it's accessible to every user on your domain. Another kind of attributes are non-replicated attributes. So the attribute value are not synchronized between domain controllers. So for instance, if we take an example with logon count, so if the Gimli goes on the DC1 and the logon, so on the DC1 the counter will be incremented, but on the DC2 and DC3 the counter won't be incremented. So if you want to know how many times Gimli logged on your domain, you need to get the 3 NTDS and addition the logon count together, all the logon counts. So those kind of attributes, if you have only one copy of your NTDS, you cannot trust them. Usually, Microsoft documents on his website if they are replicated or not, normally. And the last kind of attributes are dynamic attributes. We call it dynamic because they are not at the Active Directory installation. They are added after by third-party software, like Labs, Legacy, for instance. So when you install Labs, this solution modifies your Active Directory schema and add new attributes in your Active Directory. So to retrieve the Labs password, for instance, first of all, you need to look at the LDAP name of Labs password, which is MS MCS IDM password. And when you have a match, it means Labs is installed on the domain. You have to look at the special ID, int ID. The column is called int ID. And then you will be able to retrieve the right column to get the Labs password. So you don't need the MIS object for this one. You just need to go. But each time on each new domains, it's different. So now I will let Florian talk about the SD table and ACL. I'll also talk about our little scripts.
Thank you, Bastien. So yeah, for now we were mostly focusing on the data table and what kind of interesting findings we have when we look at the configuration of users, machine, system, and so on. But the ACL topic is very trendy, and we wanted to add that to our tooling. So first, we started by looking what was already done in the past. So mostly these two projects made by also French people, so yay. AD Contribas and BTA, they are not maintained anymore, but were a great start for us to understand how ACL works. So that was there and very helpful for us. And also, of course, Sean mentioned it this morning, and ASAP the sleeve, this white paper was really great to have a starting point in understanding how ACL work in an Active Directory, so thank you to them. So what was our plan to tackle the SD table, how to parse it, and how to identify potentially vulnerable ACL through the analysis of the NTDS. So our goal was to make a Python script to do that, because in our company we mostly use Python, and it's easy to code in Python. And we don't want to have a really big infrastructure to do that, so we just want to store the information in CSV files, from now at least. So we saw that BTA was actually made in Python as well, so for us, we were very lucky. It's not maintained anymore, but some pieces of code we think can be reused for us. So we will look at that a bit later. Also, even though in packets is really useful to pass the NTDS and at least some part of it. We saw that the dissect library from Fox IT is actually very much efficient than in Packet to do so, and it's really easy to use. We will show you that also later. And for testing purposes, we used LOID, which is an Active Directory environment that can deploy easily on AWS. So if you wanted to play with permissions, set new permission, perform an extract of the NTDS and see what it does on the data, it was convenient for us. And for the future, yeah, we want to have the same terminology than Bloodhound when it comes to the ACE edges that we identify. So, for example, the white owner, white account restriction, and so on. So, yeah. So how do we find the ACL for an object in the NTDS? So let's take an example. So first, we look at the data table, which contains information for every object in the Active Directory. And let's pick a specific object here, Aragon. So we see that its ITsecurity descriptor is 296. And that is really important for us because we want to cross-reference that with the SDID value in the SD table, which contains the data related to the security descriptors and so the permissions on the objects. So in the SD table, we look for the SDID value that matches 296, and we grab the SD value that contains the actual permissions on the object. So in practice, how does that look? So with dissect, it's just a few lines of code to parse the SD table and retrieve these two values, so the SDID and the raw value of the SD value. And it looks a bit unfriendly at first, but fortunately, there is some documentation about the structure of a security descriptor by Microsoft. And so the most interesting bits in the structure for us and our topic are the owner and the DACL elements. So the owner is, of course, the object that is owner of the object we are analyzing, and the DACL, or discretionary access control list, contains the actual permissions that are set on the object. Let's take a deep look in the DACL. So you can see it as an array of access control entries, and each access control entries is like that. So there is a size, a type. For us, the most interesting types are access allowed types, but you can find access denied types, because sometimes you want to deny permission to an object. But if you want to look for suspicious ACL that could be used in a pen test or so on, we just look at allowed. There is an access mask which contains the actual permissions that are set on the object, and there are some object flags. And finally, the SID of the object that has the permission or on the object that you are analyzing. So let's take a look at the object types. So basically, there are GUIDs, and they are present only where some specific ACU are set. So for example, read property, write property, or control access. Let's take two specific examples. So if in my AC I have the white property access mask with this object type, which translates to the MSDS credential link attribute that you can find in the documentation of Microsoft, you can conclude that you actually have a NAT key credential link permission on the object. And what does that mean? It means that you can perform a shadow credential attack and take control of the object if you have a PKI infrastructure in the environment that you are auditing. Second example with the control access mask and this object type, which translate to the user force change password extended right. It means that you can force change password of the objects that you are analyzing. So by doing that and iterating over each AC, we can conclude what permissions an object has over another object. And there are some specific cases for the GUID of the object type and inherited object types, so the zero GUID, or even when there is no GUID, which means that you actually have all the permission, you have the rights on all the properties or extended rights on the object. So for example, white property with a zero GUID, you can write any property on the object. So in practice, to parse the ID value, the BTA project was very helpful for us because we could take its code and readapt it a little and make it work. So it helped us translate the binary data to a more friendly, readable JSON structure. And in this JSON structure, you can actually find the table of the ACL structures that I showed you earlier. So now let's take a practical example. Let's say I am an administrator and I want to configure the modify owner right on the Aragon object for Gimli. So I will use ADSI or any PowerShell scripting to set up this permission for Gimli or on Aragon, and you can see on the right screenshot that it is actually set. So Gimli can modify the owner of the Aragon object. In the Bloodhound world, it would be like that. You would see this edge after running Sharpound and importing it in Bloodhound. So you have a white owner edge from Gimli to Aragon. So let's do what we did earlier to find these privileges in this table. So first, we find the ITsecurity descriptor of Aragon, and then we look for in the post SD table for the DSL of the object that matches the SDID 296. So it looks a bit like that, which is, you will agree, much more readable than before. And now we have this big array that contains all the ACE, and so we iterate over it to analyze all the permission, and we finally end up on this ACE. So we can see that there is an access type, access allowed, a white owner flag set to true, and an SID. And this SID, if you look in the parse data table, we can actually see that it is actually Gimli. So what this structure means, it means that Gimli has the white owner right on Aragon, which ITsecurity descriptor is 296. So we made a script that automates this process and dumps all the suspicious ACL into a CSV file. And so if we were to take the example of Bloodhound that we showed before, the white owner edge is represented here in our script. So you have Gimli that have, indeed, white owner rights on Aragon. So final words, we released an open source script in Python that does automate all of these, or the parsing and dumping of data table and SD table in CSV files. So it's really easy to use, just have to provide it with the NTDS and the system Hive, and it will do the work for you. So you will find all the information on the GitHub. It looks like this. So we put some calculation of execution time for each function. Usually, the bigger the NTDS, the longer it will take, especially for the parsing ACL parts. And the tool dumps the data in 6 different reports, matching, well, domain data, group data, user data, suspicious ACL, trust data. And we still have some work to do on the script. There are some bugs that are somehow related to the library that we use to parse the NTDS, so dissect. And there are open issues on the project, but it will not be treated in the coming year, I think. We have also some way of improvement regarding the new labs attributes that are not incorporated at the moment, and we haven't made the mapping for the generic call, generic write permission on that. Just a matter of deciding what write, what sum of writes the objects have, and do that. So it will be done in the future. Also, things that we want to do to improve the tool are maybe to Dockerize everything and have something that is really ready to use and everywhere. Maybe use a proper DB to store the object, because actually at the moment we are just using CSV files and doing all the parsing in Python without actual storage of the data. We are thinking of doing some interactions with Bloodhound, for example, being able to translate our data into Bloodhound compatible data so that it will be ingested in the tool and that it draws the beautiful graphs. So we could maybe perform a Bloodhound audit directly from having the NTDS, which would be really cool. And maybe enrich the data that is in the Neo4j database by actually pointing out which user will use the same passwords that would allow us to identify more attack paths in Bloodhound. Also, we think that we have some work to do on the ACL for some containers or GPO, so that will be also something for the future, and maybe collecting even more interesting attributes. So Bastien talked about dynamic attributes like labs, but other tools from vendors can also modify the schema of the Active Directory. So we saw, for example, in Pentest that some tools actually had an attribute that is readable by all users, and that contains the MD5 of the password of the user. So that would be interesting to recover. And yeah, if you have suggestions, do not hesitate to put us an issue on GitHub. We'll be happy to treat it. And also, if you have pull requests, they are welcomed. Oh yeah, we're good.
Thanks, guys. Any questions? All are good. Thanks again. Where's one? Sorry.
Yeah, just have one question regarding the tool set that you are going to provide. Do you have like any roadmap on what you want to still continue to push? I mean, contribute to the community on the script. Like, what is the next step for your parse NTDS script?
I think adding new attributes, extra attributes, just like we have talked just before, and also I think put everything in the MongoDB database. That it could be interesting to perform most sophisticated requests for audits after.
Any other questions? Okay. Thanks again.
Thank you.